Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will talk about waves. We will study waves by solving past paper questions. And today's question is from October-November 2017. For this question, first of all, we need to understand this apparatus. Means the understanding of this apparatus is very important. If we look carefully, it is given to us that there is one speaker that is fixed at the top of the tube. And this tube is initially full of water. And we also have one tap that is fixed at the bottom of this tube. By opening this tap, we can lower water level. By releasing the water means the water will come out when we open this tap. And it is also given to us the first loud sound is heard when air column, the length of air column that is equal to x, means when the length of air column that is equal to x, we hear first harmonic, or we can say that is first loud sound. We can also say that this is when first time resonance takes place, and the next time means the next harmonic, or we can say the second harmonic is heard when the length of air column is equal to y, means the second time resonance takes place when length of air column that is equal to y. Now if we look at this setup carefully, we can see here is the water, so this end will act like a closed end for air particles. So we'll say this end is a closed end and this end is open end. Now as you can see here, one end is closed and one end is open, so it is simply one end closed pipe. One end closed pipe simply tells us that only odd harmonics are produced, mean only odd harmonics will be produced. So what exactly it means, odd harmonics? It means that first harmonic or the first loud sound we will hear when the length of air column that is equal to lambda by 4. And the second harmonic we will hear when L is equal to 3 lambda by 4. For this question, it is given to us first harmonic is heard when x, the length of air column that is equal to x. So we can simply say x is equal to lambda by 4. And the second harmonic is heard when y, the length of air column that is equal to y. Simply we can say that is, this is 3 lambda by 4. And what we need to find out, we need to find out the length of sound. So we can simply subtract, means we can subtract x from y. We can say y minus x. So this is 3 lambda by 4 minus lambda by 4. If we subtract, we will get this is equal to lambda by 2. We can find lambda by multiplying y minus x with 2. So this is our final answer. If you want to draw the stationary wave, you can also draw like this. Maybe you can understand better like this. So this is the first harmonic, the stationary waves formed, and the second harmonic is formed. So this is for second harmonic. How stationary waves are formed inside. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will talk about principle of superposition, and then we will answer some past paper questions using this principle. First of all, let's try to understand what is principle of superposition. Principle of superposition is a very simple principle. We can use this one to add two or more waves, but waves have to be of the same type, and then the total displacement at any point will be equal to the sum of the individual displacements at that point. So here we have to be very clear about 2 points. The first thing we need to understand, what does it mean by same type? Same type means you can add sound with sound, or you can add light with light, but you cannot add sound with light. The second thing we need to understand is displacement. Displacement is a vector quantity, so displacement can be positive and displacement also can be negative. Let's try to visualize principle of superposition with the help of simple animation. As you can see here, two waves are approaching from two different directions. At this point they meet each other. Now how we can find the resultant wave at this point? Simply we need to add the individual displacements. For example, you can see at this point these two waves, they have the same displacement. So now we will just add these two displacements together. So you can see here they have equal displacement and they have positive displacements, so we will simply add, and this process we will repeat for all the points, and then we will just connect all the points and we will get the resultant wave. And now on the negative side we can also see these two waves, they have the same displacement, but this time the displacement is negative, so we will add negative with negative. So here is how we will add. So we repeat again for the next point. You can see here again we added these two displacements, and same for the next point. You will do this one for many points. For all the points you will repeat the same process, and now we're just gonna connect all points together, and so here is our final wave. Let's try to understand a little bit about what is constructive interference and what is destructive interference. Constructive interference simply means that when two waves they meet and they are in phase, so they will interfere constructively and the resultant displacement will be greater. Means the resultant displacement will be maximum, as you can see here. On the other hand, when two waves they are in antiphase and they interfere with each other, they will cancel each other, and that interference we call is destructive interference, and the resultant displacement will be minimum. It just depends on displacement of two waves. If they have the same displacements, and resultant displacement will be 0. Now we will use concept of principle of superposition to answer this past paper question. As you can see here in this question, it is given to us that two signals are approaching each other. One signal is approaching from left side and the other signal is approaching from right side, as you can see here, and these two signals they completely overlap each other, and we need to use principle of superposition to find the shape of the resulting signal. It's a very simple question if you are clear about principle of superposition. So let me explain to you how you will find the final answer. As you can see here, I have already drawn for you. So you can see here these two signals, they completely overlap each other. So at this point you can see we have two signals. As you can see here in this diagram, I have added these two signals together. I use red color for this signal approaching from the right side, and I use black color for the signal approaching from left side. And the blue color is telling you the shape of the resulting signal. So in this case, our final answer will be A. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will talk about waves. In this lesson, first of all, I will explain you some concepts about waves, and then we will apply those concepts to answer some tricky and challenging questions. First of all, let's try to understand what are transverse waves. So the better way to understand transverse waves is by just looking at motion of one medium particle. As you can see here, if we just focus at motion of this medium particle, we can simply see that this particle is vibrating up and down. And in this case, wave is moving to the right, mean energy is traveling to the right. So as the particle is just moving up and down, we can redraw here, and this is motion of medium particle. Mean particle is just moving up and down. And if we look at direction of wave, so in this case, wave is moving to the right. And the angle between oscillations and wave is 90 degrees, and this type of waves we call them transverse waves. Simply we can say in a transverse wave each particle vibrates up and down, and these vibrations mean the vibrations of medium particles are at right angles to the wave direction. So this type of waves are transverse waves. Examples of transverse waves are electromagnetic waves, are simply we can say EM wave. All EM waves are transverse waves. Let's try to understand some basic terms about waves now. The first term we need to understand is time period. It simply means time taken for one complete oscillation. So this one is one complete oscillation, or simply we can say this is one complete wave. So the time taken to complete one oscillation, that is called time period. The next thing what we need to understand is frequency. Frequency is simply the number of waves passing any point each second. It simply means that the number of waves passing any point per unit time is called frequency. Wavelength is the shortest distance between two consecutive points that are in phase, or we can say in step. So or simply we can say the shortest distance between two crests. Particle at this point, so and a particle at this point. So these two particles of medium, they will always be in phase. So we can also take the distance between these two medium particles. So this one also we can say this will be equal to 1 lambda. So this is how we can define wavelength. Let's try to understand what is amplitude. Amplitude simply we can define is the maximum displacement of a particle from its equilibrium position, or simply we can say from rest position. So rest position is simply a place where an oscillating particle will finally come to rest when there is no disturbance in the medium or when there is no wave passing through medium. If we look at this diagram, simply you can see this is defined amplitude, and in this case this line, this is the rest position. When there is no wave passing through the medium, particle will finally stop there. So this is how we can define amplitude. Wave speed is very important concept, and a proper understanding of this concept can help us to answer a lot of questions from this chapter. Wave speed simply we can say that is the distance traveled by the energy per unit time, and this is very similar to classical definition of speed. Means simply speed is equal to distance traveled divided by time taken. Now how we can actually define wave speed? So the best way to define wave speed simply is number of waves passing a point per second multiplied by distance traveled by one wave. Another way to say is that the number of wavelengths passing a point per second multiplied just by one wavelength, the length of one wave. This one simply actually is the frequency, means the number of waves passing through a point per second, that is the frequency, and the wavelength simply is this. So this is the wavelength, and if we multiply these two we can get the speed of a wave. Now let's try to understand this one with one simple example. Let's say this is a point, and through this point 3 waves pass in 1 second. So simply then we will say the frequency of the wave is 3 hertz, as you can see here. So we can simply say the frequency is equal to 3 hertz, means the 3 waves pass a point per second. And the second, if wavelength of this wave is also given, you can see this is one wavelength. This is one wavelength, and wavelength in this case is equal to 4 meters. So our speed in this case simply is equal to 12 meters per second. Until now we have discussed some basic concepts about waves. Let's try to use those concepts and answer this question from past paper. And this question is from October-November 2019. In this question it is given to us that the frequency of the wave is 2.0 hertz. So we can simply write down this is the frequency of the wave. So this is 2.0 hertz. This is given to us. As if we look at the x-axis, this is distance traveled by the wave, and this one is the complete wave. So this one is one complete wave. So we can say the length of one wave, this is what we call is lambda, and this is equal to 2.0 meters. So we can simply figure out the speed of the wave. The v is equal to f times lambda. So in this case the speed of the wave is 4.0 meters per second. Now what question is asking us? Question is simply asking us which diagram shows the position of the wave at time t is equal to 0.5 second, and this is what is given to us, that is at time t is equal to 0. Now we understand the speed is given to us and time, so we can find out the distance traveled by the wave. So distance traveled simply will be equal to v times t. So v is equal to 4 meters per second, and the time is 0.5 seconds. So this is simply equal to 2 meters. So it means in this time wave will travel distance that is equal to 2 meters. So it means simply the wave just one complete oscillation. So our answer will be t. As you can see here, this is the distance traveled by wave in time 0.5 seconds. We can also answer this question using a little different technique. As in this question, it is given to us that frequency is equal to 2.0 hertz. We can calculate time period. So time period simply is equal to 1 over frequency. If we divide 1 by frequency, we will simply get it is 0.5 seconds. And so this is the time period, mean time taken to complete one oscillation, or simply we can say in this time particle will complete one oscillation. If we look at question is also asking us position of the wave at time t is equal to 0.5 second. As t is equal to time period, so it means in this time period particle will complete only one oscillation, or simply we can say one more complete wave. And so our answer is D. So this is one complete wave. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, I'll explain longitudinal waves with the help of past paper questions from Cambridge AS Physics. This question is about longitudinal waves, but we need to be very clear about longitudinal waves to answer this question. Let's try to understand what exactly longitudinal waves are. If we look at this animation, we can simply see that the particles are moving to the right and to the left. And in this case, the wave is moving to the right. So if we just focus at one particle, as I have already drawn rectangle, you can see how this particle is moving. This particle is moving to the right and left. Or simply we can say the vibrations are parallel to the wave direction. So if the particles are medium, they're vibrating like this, we call these are longitudinal waves. Let's try to understand a little bit more about longitudinal waves. As you can see here, in this region, particles are close together, and this region we call is compression. And next region, particles are away from each other, that region is called rarefaction. And next one again is compression. And the distance between two compressions or rarefaction is called wavelength. Let's try to answer this question now, because now we have basic understanding of longitudinal waves. So this question is simply asking us which point on the graph is the center of compression. So compression simply means that if the particles are moving towards each other like this, so that will be compression. So this is the point we need to understand. Next one, rarefaction will be like this. The particles are moving like this, you can see. So in this case, particles are moving away from each other. So this will be rarefaction. Rarefaction. Now, if we look at this graph, now we can see the displacement is positive and displacement is negative, then displacement is positive, then it is negative. Displacement positive, let's say we take to the right as positive. So it's simply telling us particles from here to here, means particles between O and B, they're just moving to the right. And displacement is negative between B and D. It simply tells us particles are moving to the left. So simply we can find out this will be the center of compression. Now if we look at after D, so let's say this point is E, between D and E we can see particles are moving to the right. So it means the center of compression is at B, at point B, and center of rarefaction is at D. So simply we can answer, in this case our answer will be B. So let me explain you a little bit more if you are not clear how we got this answer. You can look at this diagram now I have drawn here for you. So this is our point B and this point is point D. If you look at this point at point B, this is center of compression. You can see these particles are moving towards each other. So this is center of compression. So if we look at point D, you can see this particle is moving to the left and this particle is moving to the right. So this is center of rarefaction. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will discuss a typical problem about stationary waves in pipes. For this question, it is given to us that a loudspeaker produces sound of frequency 1200 Hz and a stationary wave is produced in the tube and the nodes of the stationary waves are where we see the powder. So it simply is telling us that these points are nodes of stationary waves. So simply we can also label them as you can see here. So all these points are nodes of stationary waves. So here we can see all these nodes. It is also given to us that the speed of sound in air is here. So this is 336 meters per second. What we need to find out, simply we need to find the value of distance x. Means we have to find the value of this distance x. Now how we can find out? First of all, you can see here as the frequency of the sound is given to us and the speed of sound is also given. So simply we can find out the value of lambda. So that will be equal to v divided by f, and value of v is given. We simply need to just divide the speed by frequency, and frequency is 1200 Hertz. If we simply divide this one, we will get value of lambda. In this case, that is equal to 0.28 meters. Now the next thing what we need to understand is that is about the distance between two consecutive nodes. And distance between two consecutive nodes, this is equal to lambda by 2. As you can see here, I have already drawn this stationary wave. If you look at this point, this is node and this point is also node. And the distance between two consecutive nodes, this is equal to lambda by 2. So this is lambda by 2. So in this case, you can see how many lambda by 2 we have. So this is one lambda by 2, this is second one, and this is third one. So this is also lambda by 2. So simply we can write down x in this case is equal to 3 times lambda by 2. Or simply we can also write down this is equal to 1.5 lambda. Now simply we need to plug in value of lambda. In this case, lambda is 0.28 and our final answer will be 0.42 meters. Or simply we can say this is equal to 42 centimeters because answer is given in centimeters. So our final answer is B. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will talk about type of waves and their approximate wavelengths. And this is very important for Cambridge AS Physics exam. For this question, 4 different electromagnetic waves with possible wavelengths are given. Simply, we need to find out which row is correct. If we look at option A, type of wave is infrared and its approximate wavelength in meters is 10 to negative 5. So if we compare with actual range of infrared, we can simply see that it is in this range. So we can say this one is correct option. Now, if we go to option B, type of wave is radio wave and its approximate wavelength is given, that is 10 to negative 3. If we compare this one with actual range, we can simply see that actual wavelength of radio waves is greater than 1 meter. This is shorter than 1 meter. If we look at option C now, UV, and its approximate wavelength is given, and if we compare this one with actual range of wavelength, simply we can see that this is out of range, so this is not possible answer. Now the last one, type of wave is X-rays and its approximate wavelength is 10 to negative 7. If we look at actual range of wavelength, we can simply see that this is out of range. So our answer for this question is simply A. Now the problem is that if this table is given, it's very easy to compare, but if this table is not given, it's very difficult to find. Let me explain to you approximate wavelengths for electromagnetic waves. First of all, for radio waves, the approximate value of wavelength is 10 to 2 meters. For microwaves, this is 10 to negative 2 meters, or simply you can remember this is about 1 centimeter. For infrared, approximate value of lambda is 10 to negative 5 meters. For visible light, this is about 10 to negative 7, but it's better if you can remember this one in nanometers. In nanometer, it is about 400 to 700 nanometers. For UV, approximate value of lambda is 10 to negative 8 meters. For X-rays, it's equal to 10 to negative 10 meters, or it is equal to size of atom. And for gamma rays, approximate value is 10 to negative 14 meters, or it is equal to size of nucleus, typical value of size of nucleus. So this is all you need to remember for your exam. If you can remember these approximate values, you will be able to answer past paper questions. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will discuss how to use Doppler effect to answer past paper questions from Cambridge AS Physics. For this question, it is given to us that a train emits sound of frequency F1 and the train is approaching a stationary person, means the person is at rest. Approaching. So this is very important point. In this case, source is approaching listener. It is also given to us that the speed of the train is 0.20 v and v is the speed of sound in this case. Frequency of the sound heard by the person is also given and that frequency is F2. Simply we need to find the ratio between F1 and F2. Let's try to see the clear picture of this question by sketching. Imagine that this is our train and this train is moving to the right and the velocity of this train, the velocity of the source is given, that is 0.20 0.20V, and this source of sound emits sound waves, and frequency of the sound waves is given, that is f1. Imagine that a listener is standing in front of this train, and this listener is at rest as it is given in question, and the frequency of the sound heard by this listener is given, that is f2. Let's try to write down Doppler equation when the source is approaching listener and the listener is at rest. So simply we can say observed frequency in that case will be equal to speed of sound over speed of sound minus speed of source multiplied by frequency of source. In this case f naught, this is observed frequency. We can simply say this is observed frequency, and in this question observed frequency is equal to f2. fs is the source frequency, so we can also say this is frequency of sound waves produced by train. So f1 is fs. V is the speed of sound. We can write down here the V is speed of sound. Vs is speed of source, or we can say this is speed of train in this question. So speed of train in this question. Now simply we need to plug in values to find the ratio between f1 and f2. In this case f naught, as you can see here, this is equal to f2, so we simply need to replace f naught with f2. fs in this case is equal to f1, and the vs in this case is equal to 0.20, so we simply need to replace this with 0.20 times v. We can write down here in this case f naught is equal to f2, and this is equal to v over v minus vs multiplied by f1. We can rearrange this. We can write down f2 divided by f1. This is equal to v over v minus vs is equal to 0.20 times v. Now if we simplify this, we can take common v from here. We can write down 1 minus 0.20, and if we further simplify this, we can write down f2 over f1. This is equal to v. We can cancel with v. This is equal to 1 over 0.80. But this is not our final answer. As you can see, question is asking you to find the ratio between f1 and f2. We can cross multiply this one. We can write down that 0.80 f2, this is equal to 1 times f1. As we need to find the ratio between f1 and f2, we can divide these two sides by f2. So we can also divide here by f2. So this will be cancelled with this. So we left with 0.80 on left side, and on right side we have f1 divided by f2. So if we divide by 1, actually you don't need, but if you want to understand in detail, so we can divide by 1 on both sides, so we can cancel 1 with 1. So finally f1 over f2, this is equal to 0.80 divided by 1, and this is our final answer. So option A is correct. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will talk about Doppler effect. I'll explain you what exactly Doppler effect is, what are Doppler effect equations, and how we can use these equations to answer past paper questions. Let's try to understand what is Doppler effect. Doppler effect is simply the apparent change in the pitch of the waves, and that is simply caused by relative motion between the source and observer. Mean is the apparent change. Apparent change means this is the change for listener, but the original frequency of sound waves is not changing. If we look at this truck, for example, you can see the truck here as it is given in the example. You can see as this truck is at rest and this truck is not moving. As the truck is not moving, the listener standing here and listener standing here, they will perceive the same frequency. Doppler effect is all about relative motion between listener and source. If there is no relative motion between listener and source, there will be no Doppler effect. So we have to be very clear. There must be relative motion between listener and source. Let's try to understand when the truck is moving. As we can see here, truck is here and this truck is moving to the right. There is one female, she is standing in front of the truck, and there is a male who is standing behind truck. As the truck is approaching to the female, so this female will perceive higher frequency, or we can say higher pitch, and this male, this person standing at the back, will perceive lower pitch. The reason is that the person standing in front of the truck will receive more number of waves in a given time, means the number of waves he is receiving per second will increase, so he will perceive higher frequency, and the person standing at the back will perceive lower frequency because he will receive less number of waves per second. So this is simply all about relative motion. If source of sound is approaching, frequency or the pitch will go higher. If the source is moving away, then pitch will go down or pitch will decrease. It's just due to number of waves listener is receiving per second. Let's try to understand when the source is approaching and the listener is at rest, means the listener is not moving at all. As the source is approaching, it simply means that the listener will receive more number of waves per second, so he will perceive higher pitch or higher frequency. So how we can calculate that observed frequency by listener? So f prime is observed frequency by listener, and f is the frequency of sound waves produced by source, and v here is the speed of sound waves, and us is the speed of source. If these things are given to us, you just simply need to plug in and you can find out observed frequency. As we can see in this case, this is minus. Why we are using minus here? Because the source is approaching, so the observed frequency will be higher than source frequency. That's the reason we have minus sign here. So when source is approaching and the listener is at rest, you simply need to use minus because observed frequency has to be higher. Let's try to understand when the source is moving away from listener and the listener is at rest. So you can see here, as in this diagram, our source is moving to the right. So here is source, it is moving to the right, and the listener is standing on the left side and the listener is at rest. So in this case, we can simply understand the number of waves this person will be receiving, listener per second, will go on decreasing. So he will perceive lower pitch. And how we can calculate the frequency he will perceive? That frequency we can call f prime, or we can also call observed frequency. means the frequency he will observe. And this is the frequency of the source, and here v is the speed of the sound waves in the medium, but this u s sub s is the speed of source. In this case, observed frequency will decrease. That's the reason we're using plus sign here. Let me explain to you how to use Doppler equations. The first one is only for moving observer, or you can say for moving listener, when the source is at rest. If the source is at rest and only listener is moving, you can use this equation and you can calculate the observed frequency. So if the listener is approaching, then you have to use plus sign here. And if the listener is moving away, you have to use minus sign here. Plus sign when it is approaching, simply because the observed frequency will be higher. And when the listener is moving away, he will perceive lower pitch. That's the reason we are using minus sign here. And the second one is for moving source, means when only the source is moving and observer or listener is at rest. By using this one, we can calculate observed frequency. This frequency, when you are calculating, you need to be careful. You need to check, is the source is moving away or is the source is approaching. If the source is moving away, we will use plus sign here, means we will add these two speeds. And when the source is approaching, we will use minus sign here. So when the source is approaching, observed frequency will be higher. So we will subtract u sub s from speed of waves. So this is all about Doppler effect. This is how you need to use these equations. Get familiar with these sign conventions. Here is question from CAIE AS Physics, and this question is based on Doppler effect. Let's try to apply our understanding of Doppler effect and Doppler equations to answer this question. So you can pause this video. First of all, you can try this question by yourself, and then you can come back and you can compare your answer with my answer. If we read this question, it is given to us that the frequency of source is 1000 Hertz. We can say this is frequency of source, and the source is moving at speed 20 meters per second. We can say this is speed of source, and the source is approaching observer and observer is at rest, and the speed of sound in the air is given here. What we need to find out, simply we need to find out observed frequency, means the expression. We don't need to solve, we simply need to write the expression for that. So from our understanding of Doppler effect, we can simply write down the equation when the source is moving and the listener is at rest. So this is what we have discussed when the source is moving. So this was our equation when the source was only moving and listener was at rest. But now we need to understand whether we use positive sign here or negative sign here. In the question, it is given to us the source is approaching. Source is approaching, so it simply means that observed frequency will be higher, means the listener will perceive higher pitch. Listener will perceive higher pitch. So higher pitch is only possible when we use minus sign here. So our equation when the source is approaching, we can write down will be speed of sound minus speed of source multiplied by frequency of source. In this case, the speed of sound is here. This is v. So we can write down the speed of sound in the medium divided by speed of sound minus speed of source. So this is speed of source, and we simply just need to multiply with frequency of source. So in this case, frequency of source is 1000. So we can simply write down here frequency of source is 1000. So in this case, our answer will be B. So this is our final answer, and this is how we can use Doppler equations.